Hi, welcome back to my channel. Today we will discuss about EIGRP matrix calculations and matrix calculations is actually very useful topic when you are doing CCNP route. There are lots more cover in CCNP route, whereas in CCNA routing and switching there are lots of topic has been covered in CCNA routing and switching. And when you are doing routing and switching, you should be known about the how EIGRP calculation, EIGRP matrix calculation is happening. So as you know that this matrix calculations play a very important role while selecting routes among the multiple route to a destination. So there are multiple ways that the different protocols work on matrix calculations. If we will talk about RIP, so RIP basically use hop count to calculate the matrix, and the lowest hop count will consider as a best route. So in the similar situations for EIGRP again uses composite matrix in case of selection of routing best route. So again, you can see that the composite means that there are multiple things, possible things which is being considered to determine the matrix. So that is why it is called composite matrix for EIGRP. And basically these are the values. These are the things which are being in considerations while deciding the best matrix while calculating the matrix. So there are total 5 factors which is being in considerations while selecting route, and if you can see that these are all different factors. So bandwidth, delay, reliability, load, and k values. So k values is actually which is being decided on the router, and it has actually default values by default. And but you can always change by using a particular command of the key values. And we might have heard about MTU as well. So MTU is not deciding, it does not participate in deciding the matrix, right? It only participates when there is equal cost load balancing has been configured, and in a case where the packet has been to transfer from the two different paths, so that lowest MTU size will be considered first, and the highest will be considered second. So MTU doesn't play to decide the matrix, but it plays when our lowest path, when equal load balancing, equal cost load balancing has been configured. This is the raw formula in case of matrix calculations, and this formula has been taken from Cisco Learning website. So if you can go to the Cisco Learning website, you will find this formula over there as well. The second part comes with the bandwidth. Here the bandwidth means this bandwidth mean. So bandwidth means actually 10 to the power 7 divided by least bandwidth, and you will have to multiply with 256. So this is actually bandwidth. Bandwidth means bandwidth actually this equals to complete formula, right? Again, delay is a complete formula where some of the delays on the path. So this was the least bandwidth, but here you will have to take this was the least bandwidth, but here you will have to add all the delays in the path, and then you will have to multiply with 256. So this is called actually bandwidth and delay. And again, here are the k values. So k values in factors, the k1 is, this is the actually default value, and you can always change by going to the command prompt when you are configuring EIGRP, router EIGRP, and then you can go and change this matrix from there. This formula has two portions, right? So one portion starts from here and ends here. So this is the one portion. Second portion is here, right? And since k5 is equal to 0, so k5 0 divided by whatever it is, it will be equal to 0 only, and 0 is going to be multiplied with this value, so everything will be 0. But in case of EIGRP, what EIGRP matrix calculation says, when you are going to, when a particular sections going to be 0, then it will drop this particular section. So suppose it is 0, then it will be chopping out all these sections from the formula itself, so nothing will be remain. You will be calculating based on these values only. So you will have to consider that this has been already chopped in case you have K5 made at 0. I mean, this is already default value in routers, right? So let's discuss about this matrix now. And here since it's been 0, I mean, I'm trying to put the formula, whatever the values are there by default, I'm going to put into the formula. And if I will put this K1 is equal to 1, again here K2, so K2 is equal to 0, and this is a whole bunch of formula. I mean, you can pause the video and you can see that it's been completely this value has been kept under this formula only. So finally it becomes like matrix is equal to bandwidth plus delay. I mean, everything will be chopped off to be I mean, everything will be 0, and it will remain as a bandwidth plus delay. Bandwidth is again 10 to the power 7 divided by least bandwidth into 256, and path is equal to sum of the delays on path and 256. So finally this formula is going to be reduced by 10 to the power 7 divided by least bandwidth plus delay, and you will have to multiply the whole values in whole values by 256 only. So let me write it down here. It will be something like this: 10 to the power 7. Right now I'm using mouse button, and that is why I'm having inconvenience. So 10 to the power 7 divided by bandwidth and plus delay, and you will have to multiply whole this by 2, 5 and 6. Here is the next sections with example. And finally the matrix, this matrix becomes like 10 to the power 7 divided by least bandwidth plus delay into 256, and this is the topology used for an example. See, I have been already configured with the required IP addresses on this, and it is completely working. I can ping from PC1 to PC2. Okay, and let's see that. So IP interface commands will tell you that what are the values has been given on this particular interface. So if you are going to send something, means least bandwidth means that the lowest bandwidth going to be on path. So whether this value or this value, it should be the lowest one, and that will be considered as a least value here. So here you can see, if you will do the show IP EIGRP topology and destination, you will find this particular bandwidth, and again the delay in microseconds. It shows like this here. How it has been calculated? It has been calculated based on this delay. So delay is actually delay on this interface and delay on this interface. So delay on this interface is 10 U seconds, and again let me tell you what is the delay on this particular interface. And here is the delay 100. Okay, so as I said, this is the topology I'm going to use, and here is the details of the of this route. You can see that on this interface, I mean on this particular interface, the value of delay is 10 USC, and bandwidth is this one, right? Again on router 2 as well, here it is, the bandwidth is this one and delay is this. So if you will so what will be the delay? Delay will be like addition of all the delay on the path. So this one and plus this one will be the delay. So this delay is going to be 110, it's equal to 110, and bandwidth is going to be the least one, and in this case I see that both the bandwidth are same. It's a 10 to the power 6 actually. So it's a 10 to the power 6, right? We will put this into the formula, and we will quickly use the calculator to decide if it is matching to the configuration or not. And before I calculate anything, let me tell you what is the feasible distance. This is showing right now. So I was trying to solve the topology for 192.168.3.0, which is actually this network, and that feasible distance is this one. So 5376. And how it has been decided? So take this 10 to the power 7, 10 to the power 7 is equal to this, and divided by that the value I have here. So it's 1 2 3 4 5 6, right? It's become 10 and plus. Okay, before I do the plus, let me tell you this value about this delay. So delay, if it is 110, it's mean that you will have to take the value tens of 110. So tens of 110 will be like divided by 10. So it will be the actually d is equal to 10 11, right? So let's add this here now. Plus 11 into the next one was like 256. So this one is 256. So into 256. Here you go. So 53776, and this is what it was showing on the router itself while we were doing to the topology. So 537. So IP topology, so IP EIGRP topology 5376 and 5376. Here it is, right? So and yes, whenever you will change the value of your k, suppose you change something on k value, then definitely it is going to be change the complete value over there. So by default it used to be k is equal to 1, k2 is equal to 0, k3 is equal to 1, k4 is equal to 0, and k5 is equal to 0 again. Thank you. Let's see in the next video. I will be covering on some more topics on EIGRP itself. So we'll see you in the next topic.